Okay, so I promised quadratics, and that is exactly what we're going to get in this video. So we are going to look at an example which is solve, and we're going to have a quadratic, so it's going to be 4 sine squared of x plus 11 sine x plus 6 equals 0. And we've got some kind of range, again, keeping that nice and simple here, just between 0 and 360. Now, this may not look much like a quadratic, but we've got a squared term, we've got a term without a squared, and we've got a term with no thing at all. So if I could kind of parallel this equation here and say, well, that's really the same thing as 4y squared plus 11y plus 6 equals 0. It's exactly the same equation if y here was just a sine x, because we're doing sine x and we're squaring it. We've got, instead of our y here, we've got sine x, and then we've just got a plus 6 added on the end. So this is just going to help us think through what we would do to solve this, and then hopefully we can use our answer to solving this to help us solve the original equation. So how would we go about solving that? Well, the first thing would be to factorize. So we'd want two things that multiply to give 24 and add to give 11. A little bit of thinking with that should tell you 8 and 3. So we have 4y squared plus 8y plus 3y plus 6 equals 0. We then want to factorize each half. So this is our technique for factorizing. Remember, we've got to use this method when there's a number in front of our squared term. So we can take 4y out, we end up with y plus 2 in the bracket, plus, and take 3 out of that and end up with y plus 2 in a bracket. That's good. Brackets, both y plus 2. So our final factorization is 4y plus 3, y plus 2. Okay, so we've kind of used this bit of algebra to help us think what's going on here, but this would be exactly the same. So we can actually apply, instead of our y's, we can have our sine x's. So this thing here should factorize as 4 sine x plus 3, and instead of that y, put a sine x in, plus 2 equals 0. Okay, how would we proceed from there if we're solving this quadratic? Well, we'd say if this thing here equals 0, then either that bit equals 0 or the y plus 2 equals 0. So we're going to do exactly the same here. So either our 4 sine of x plus 3 bracket equals 0, or our sine of x plus 2 bracket is equal to 0. One of these two must be true. Well, let's proceed from there, because we've now got back to what's a very straightforward trig equation like we've been dealing with for the last 2 weeks. A little bit of rearranging gives us 4 sine x equals minus 3. And so sine x equals minus 3/4. I'm going to shuffle up a wee bit just so we've got some space. And we can proceed. This is, well, we've got two choices. We can have x equals sine to the minus 1 of minus 3/4. Or if you're using cast, you'll want your relative acute angle being sine to the minus 1 of plus 3/4. Whichever way you do it is absolutely fine. You'll get 48.590377 or minus 48.590377. This angle's not in range. Remember, we're looking between 0 and 360, but let's use our graph or our cast to find two angles that are in the right range. There's our sine graph, so our minus 48 angles along here. So we're looking for these two along here and here. Well, if that's 180, we're using our graph to spot that bit of the graph, that bit and that bit all look very similar. So we either want 180 plus our 48.590377. We'll work out what that is in a second. Or we want 360 minus our 48.590377. Our cast would give us the same result because sine is negative. Well, it's negative here and here. This one is 360 minus the relative acute angle. That's that. This is 180 plus our relative acute angle, which is that top one. So let's work these out. That one gives us 228.590377, which is approximately 228.59. The second one here gives us 311.409622, which is approximately 311.41 degrees. Good, so we've sorted out this side, and as ever, I'm just going to highlight the solutions as we go, in case we forget what we're doing. Let's go back over here. We need to solve this. Well, solving that, we get sine of x equals minus 2. This runs into a problem. Now, let's see why. And this gives us a bit of a general thing to watch out for. If I look at this graph, the top here is at 1. The lowest point here is at minus 1. So this sine of x equals minus 2 can't exist. There are no angles we can put into the sine function that are going to give us minus 2 out, because the smallest we can ever get to is minus 1. So over here, you can happily write, with no further working, no solutions. It's important you write that, because that identifies you've thought about it, you checked it, and you've decided there aren't any, rather than just kind of giving up. So it's important you write this, but that's us done on this side. If you didn't spot that, and you tried doing x equals sine to the minus 1 of minus 2 or even 2, your calculator will say error. That error is a good clue that you probably have no solutions to something. So, time for you to have a go. This is getting quite a lengthy video because these are quite long questions each time we do them. But time for you to have a go and see what you get. So there is one to solve. So pause the video, have a go at doing it, and then like the last one, I'm just going to show you the solution, run through it very quickly so you can see that. So pause the video, have a go, and I'll run through it in a second. Okay, great. Hopefully you've had a go. So what have we got? Well, instead of this equation, I've written it as one with y's in it. By the way, the reason we use y's here is because x's exist in this equation. So it's just handy to have a different letter because we're talking about something different. So changing it to y helps us there. I went on to factorize it. So my steps took me to 2y minus 1, y plus 1 there. That was my factorization. And then I put, instead of the y's, I've put cos x back into my factorization. Because that equals 0, we get two possible equations. We either get cos of x minus 1 equals 0, and that gives us cos of x equals a half, or this one here gave us cos x equals minus 1. Well, let's solve each of those. Solving cos of x equals a half, it's actually an exact value. You get 60 degrees out, and then using cast or your graph, the other angle was 300 degrees. This one does have solutions. So unlike my first example, this does have solutions for this. If we have cos x equals minus 1, working out a relative acute angle doesn't really help here. Your calculator will give you out nonsense. If you put cos to minus 1 and 1, it'll just give you 0, and the other possible angle is 3. It doesn't help. So let's draw a graph instead. Where does the cos graph equal minus 1? Well, it's at 180 degrees. So this is one of those examples where the graph is much easier to use. Apologies, that's been off the screen. I didn't spot it. So this is an example where the graph is much easier to use than the cast diagram or even a calculator. Solving that, therefore we have three answers. They were 60 degrees, 300 degrees, and 180 degrees. Okay, so that is our second variety of quadratic that we can solve, and there's a final video showing you one more variety of quadratic. And just for variety, we're going to also put in radians into that one. So stop there, and you might even want to have a go at some examples that are similar to this. I will split the examples up so you can see the different types in the examples that you're doing.